Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to take a look at area in metric units. So before we start talking about the units, let's talk about the concept of area with some basic geometric shapes. For example, if you had a rectangle and you were asked to find the area of this, you're finding how much surface there is. So the way that you're going to find area of a rectangle is length times width. If you're asked to find the area of a circle, you will be given either the diameter, which is the distance through the center from one side of the circle to the other, or the radius, which is the distance from the center to any point on that circle. And in order to find the area, you're going to take that radius and multiply by itself, so radius times radius, which is radius squared, and then multiply that to a special number called pi. Pi is a very special number, and it's actually the ratio of the circumference of a circle to its diameter. It's not a finite number, it goes on forever and ever and ever. I've written it down here to 8 decimal places, but it goes to many more. And if you have a pi button on your calculator, it will have pi to a certain number of decimal places that's more accurate than these approximations for pi. If you do not have pi on your calculator, then you can use 3.14 or 3.1416, depending on how accurate you want to be. So you're going to take that special number pi and multiply by the radius squared to get the area of that circle. If you're asked to find the area of a triangle, the area is 1/2 times the base times the height. So the height is the perpendicular distance from the vertex to the base. So I'll just put a little symbol for right angle. So that's the area of a triangle. When you're finding area, it's a two-dimensional measurement. It's amount of surface, as opposed to finding perimeter or circumference of these shapes. If you're asked to find the perimeter of this rectangle, you just add up the sides. Similarly, if you were asked to find the perimeter of the triangle, you just add up the 3 sides. With a circle, you don't have sides to add up. So the perimeter of a circle is called circumference, and it's pi times the diameter. That's not an area, it's just a length. It's like finding what length of string would you need to go all around that circle. So we're not dealing with lengths, we're dealing with areas, which is two-dimensional. Lengths are one dimension. So when you're working with circumference or perimeter, your answers will be in meters or centimeters or millimeters. But if you're working with area, or also called surface area, you're going to be dealing with a two-dimensional measurement. So your units will be square centimeters, square meters, square millimeters, and so on. Let's take a look at some examples so we can try out these formulas. If we had a rectangle that has a length of 15 centimeters and a width of 100 millimeters, we can't find the area when those lengths are in different units. So I'm going to change 100 millimeters to centimeters. To change millimeters to centimeters on my length scale, I move over one place to the left, so I do the same thing with my decimal point. So this will be 10 centimeters. Then the area will be 15 centimeters times 10 centimeters, which is 150. Centimeters times centimeters is square centimeters. In my next example, if I have a circle that has a radius of 10 centimeters, or it could be given as a diameter of 20 centimeters, and to find the area, I multiply pi times that radius squared. So you can see my unit's going to be square centimeters. 10 squared is 100 times pi will be 314.16 square centimeters. And the last example, triangle has a base of 2 meters, a height of 1.5 meters, so they're both in the same unit, so I'm going to keep them. The area will be 1/2, base is 2 meters, times height of 1.5 meters. 1/2 times 2 is 1 times 1.5 will be 1.5. Meter times meter is square meters. So that's how we use those area formulas. Let's take a look at how we deal with area units in the metric system and how we convert from one unit to another. If we took a rectangle that had a length of 5 centimeters and a width of 3 centimeters, and if we were to find the area of that, we would multiply length times width. And in this case, we would get an area of 15 square centimeters. So centimeters times centimeters gives us square centimeters. If I were to change my lengths to millimeters, and in order to change 5 centimeters to millimeters, on my length scale, it's one place over to the right. So I'd move my decimal point one place over to the right. It would be equivalent to 50 millimeters. Similarly, 3 centimeters, if I were to change that to millimeters, I move one place over to the right on my scale. So I move my decimal point one place over to the right. And I get a width of 30 millimeters. So if I were to calculate this area with my dimensions in millimeters, I would get an area of 1,500 square millimeters. We know that these areas are equivalent, but what I want you to notice here is that when the area is in square millimeters, it's 100 times larger than square centimeters, even though a centimeter is only 10 times larger than a millimeter. So there's a difference in converting area units to converting length units. Let's set up a scale using area units. So what I did is I took my length units and I squared them to get my area units. So I've got square kilometer, square hectometer, square decameter, square meter, square decimeter, square centimeter, square millimeter. And we know that to change from square centimeters to square millimeters, we had to move our decimal point 2 places or multiply by 100. That's because it's a 2-dimensional measurement. So each dimension we have to multiply by 10. Because there's 2 dimensions, we're multiplying by 10 squared. In other words, we're multiplying by 100. So the best way to do that using the scale is remember that you're multiplying by 100 each step, whether you're going to the left or the right. And that means you're moving your decimal point 2 places each step on the scale. Let's take a look at some examples. If I was asked to convert 3 square meters to square centimeters, I'm going from square meters to square centimeters, so I'm going 2 steps over on my scale. I'm multiplying by 100 each step. I'm moving my decimal point 2 places each step, so 2 and 2 will be 4 places. I'm moving my decimal point 4 places. I'm multiplying by 100 times 100, which is 10,000. So I'm going to move my decimal point over 4 places to the right. 3 square meters equals 30,000 square centimeters. If I'm going from 0.8 square decameters to square millimeters, I'm going from here 1, 2, 3, 4 steps over. And each step, remember, I'm multiplying by 100 or moving my decimal point 2 places. So if I'm moving 4 places over, I have to move my decimal point 8 places. So I have to move my decimal point 8 places. So 0.8 square decameters will be equal to 80 million square millimeters. So the numbers jump in size very quickly or decrease in size very quickly if I'm going the other direction. So 420 square centimeters, and I want to change that to square decimeters. That's just 1 step over to the left. So I divide by 100, I move my decimal point 2 places. And so on. So just remember that you're dividing or multiplying by 100 now instead of 10 each step on the scale. The other thing that I want to make a note of is that you might see an area unit called hectare. Hectares are used for measuring land areas, and a hectare, which has a symbol of h small a, is equivalent to a square hectometer. So this is the same as a hectare. So if you think of it in terms of being square hectometer, then you can do your conversion, your unit conversions easier. So if I had 2.5 hectares, and I want to know how many square meters that is, I think of it as square hectometer. And to go from square hectometer to square meter is 2 places, so I move my decimal point 4 places. So that will be 25,000 square meters. In other words, a square hectometer is equal to 10,000 square meters. Practice changing metric area units. I think the easiest way to do so is to use this scale. And in case you're asked to find areas of three-dimensional objects, I'm going to give you a couple more formulas. If we take a look at a rectangular solid, which will have length, width, and height, we could be asked to find the volume of that, which is just how much it holds. But we could also be asked to find the area of that object. So we have to know how much surface there is on all the sides of that rectangular solid. And each side will be a rectangle. There are 6 sides. There's this one at the front and one at the back. There's this one on the side and the other one on the other side. And then there's the top and the bottom. So if you're asked to find this total surface area, you're going to find, first of all, this area, which will be length times height. And you're going to double it because there's a 1 at the other end. Then you're going to find this area, which is width times height. And you're going to double it because there's another 1 on the other side. And then you're going to find this area, which is length times width. And you're going to double it because there's 1 at the top and 1 at the bottom. So this is what you use to find the surface area of a rectangular solid. It's area, so it will be in square units. If you're asked to find the area of a cylinder, the top and the bottom are circles, but the curved surface is not flat. So you have to determine how to find the area of that curved part. Well, if we were to slice it and open it up, it would actually be a rectangle. And the area of that would be this dimension times this dimension. So in terms of our cylinder, this dimension will be the circumference, and this dimension is the height. So the surface area of a cylinder will be the circumference, which is pi d, times the height, that gives us the curved surface, plus there's a circle at the top and a circle at the bottom. Each of those circles has an area of pi r squared, and there's 2 of them. So if you encounter questions where you're asked to find surface area of three-dimensional objects, keep these equations in mind. So practice questions where you're asked to find areas, and practice questions where you're asked to change units from one metric area unit to another. In the next video, we're going to talk about volume measured in metric units.